Chapter 20, problem number 44, OpenStax Physics textbook online. Let's work the problem. So it says, suppose that you have an extension cord with resistance of 0.06 amps and a current of 5.06 ohms. And a current of 5 amps. What's the power dissipated by that extension cord? Well, that's not too hard, right? Power is I times the voltage. We don't know the voltage, that's fine. I can write I times R, and so I get IR, or I squared R. Now I'll just need to put in my stuff. Power is going to be 5 squared 0.06, and I get, calculator time, well, I could probably do that in my head, that's fine. 5 squared is 25.06 times, I get 1.5 watts. That seems reasonable, right? You think about like a 60 watt light bulb. I mean, an extension cord, it does get hot. They do get hot. Okay, but now the second part says, what if it's a cheaper cord, the area is half as much? Well, if the area is half as much, remember R rho L over A, if I make that half as much, the resistance is going to go up by 2. So it's going to be twice the resistance. So R2 is equal to 0. Oh, what did that say? A cheaper cord, 0.3. So it's way higher. Is that right? A cheaper cord, it just says thinner. It doesn't say it's half as much. A is smaller, so the resistance goes up. Well, I'm going to do the same thing. P2 is 5 squared times 0.3. So that's going to be 25 times 0.3 is 7.5. Is that right? I think that's 7.5 watts. So quite a bit higher. So that wire is going to get hotter doubly so, right? It's going to have more power dissipated through the wire, and it's thinner, so there's less material there to heat up. So it is going to get a lot hotter. That one's not going to be a great wire to use for 5 amp or 0.5 amp current. Yep. That was easy. Easier than I thought.